Number 7 says, which of the following are the correct SI unit of a quantities indicated? Roman figure 1 says what? Force. Newton. Roman figure 2 says what? Newton per meter, which is torque. Roman figure 3, you see what? Watt, which is what? Power. Roman figure 4 says what? Kg meter per second square, which is what? Momentum. Now, what we want to do now in this square space now is that we want to look at the unit and the quantity, whether they are what? They are the correct unit and the quantity for that what? Particular what? Roman figure. Now, Newton for force, yes, correct. Newton is equal as force, or kg meter per second square. Is kg meter per second square. Kg meter per second square. This one say Newton per meter, wrong for torque. Newton per meter is what we call force constant, or what we call the force gradient, or what we call surface tension, which is as a result of force over length or force over extension. Force over extension is force constant from Hooke's law. The force over length is what? For surface tension. So this one is wrong. Watt for power, yes, correct. Watt for power, or joules per seconds. Joules per second. Power can also be what? Kilogram meter square per second cube. Fundamentally correct. So this one say kg meter per second square. I believe you should know that one is wrong. So this one is wrong. This is correct. This is correct. So 1 and what? And 3 is correct. The answer, option A says 1 and 2 only. B says 1, 2 and 3 only. C says 1, 2 and 4 only. D says 1 and 3 only. So the answer is option D. Number 8, say which of the following is a fundamental unit? I believe we have talked about that one before, so we'll go straight. A say Newton. No, Newton is what? For force, which is not a fundamental unit. So which of the following is a fundamental unit? B said what? What is for power, no fundamental unit. C said joules is what? C, joules is for energy. Why D, seconds, is for what? Is for fundamental unit. So seconds, option D, is a fundamental unit. So the shortcut I will advise you to do is that we cannot be writing all the derived units here. Anyone that is not part of this shortcut I gave you matters. The T is squared and the S is squared. Then take it as what? Derived unit. So that is the best way. Just memorize your what? Your fundamental unit. Anyone that is not part of this example listed on the board, then you take it as derived. So the answer for that by 8 is D. Number 9, it said what? Which of the following has the same unit as the watt? Which of the following has the same unit as the watt? A says what? Force times time. Force times time is impulse. Is impulse or momentum. B says force times distance. That is work done or energy, or even what? Torque, and it can also be moment. Option C said what? Force times what? Acceleration. No one, just forget about that. Then D says force times velocity. Power is what? Which is watt. It can be force times what? Velocity. Don't forget, power can be force times velocity. Power can be what? mgh over time. Power can be half mv squared over time. Power can be what? Work over time. Work over time, which is rate of doing work. Power can also be what? I've given you first time. It can also be half k squared over time, which is rate of work. It can also be mass, mass times acceleration times distance. So these are possible formulas I can list for now for work that you can take note of, for power rather, you can take off. So the force times velocity is the option for that, number 9. Let's go to number 10. He said what? Which of the following is the dimension of pressure? Which of the following is the dimension of pressure? Pressure is what? Is equal to force times what? Area. Force over area. You see, if there's anything dimension that you must cram before going to the exam, or that you must know, is force. Force is what? Mass times what? Acceleration. So divide by what? Area. So mass is what? After letter M for the dimension. Acceleration is what? Velocity over time. Don't forget, if acceleration is velocity over time and velocity is what? Displacement over time, which is what? LT minus 1 divided by t, which is what? The same thing as LT minus 2 is acceleration. So I will have LT minus 2 as acceleration. Then divide by area. Area is length times breadth, which is length L times L. Length is measured in what has the dimension of L. Breadth is has the dimension of L. So this will cancel this. What we have is what? M L. If this one goes up, become minus 1, then T minus 2. So this one should be the dimension for pressure. So the answer, they say what? Which of following is not A? Is the dimension of pressure. A says what? ML what? Minus 1, T minus 2. Yes, correct. That's option A. B says MLT minus 2. That should be force. Then D says ML squared T minus 3. Power. That is power. Then D says what? ML minus 3. That's density. You can try those options and see how you can find the dimension of power, density, and what? And force to confirm it. I've done that of force, which is ML minus 2. Which is also the answer is option what? A. This one says on my level says what? At what respective values of X, Y, and Z will the unit of force, the Newton, be dimensionally equivalent to what? To M raised to power X, then L raised to power Y, and T raised to power Z. Dimension of force is ML T minus 2. So if it's equivalent to what? ML equivalent to ML raised to power X, L raised to power Y, and T raised to power Z. What will it now be? Then let's do comparison. This is 1, 1. So that means X is equal to power of M is 1. So X is 1. Then Y is what? 1. Then Z is equal to what? Minus 2. So if we compare them, it's what? Option A says minus 1, 1, and 2. B says 1, 1, and minus 2. C says what? 1, minus 1, 2. D says minus 1, 1, minus 2. So the answer to that question is option B, which is 1, 1, minus 2. Number 12 says what? That is option D is the answer. Option B rather is the answer. So number 12 says the physical quantity that has the same dimension as impulse is dash. A, energy. B, momentum. C, surface tension. D, pressure. I've answered that question before. The answer is momentum, which is option B, is having the same dimension as what? Impulse. So impulse and momentum have the same dimension. Energy, moment, torque, and torque, work have the same dimension. Surface tension and force constant have the same dimension. Then pressure, Young modulus, and stress all have the same dimension. So the answer to that question for impulse is what? Momentum. Number 13. Say the correct unit of energy is what? Energy is force times distance. Energy is force times distance. And force is what? Energy is equal to what? Force times distance. So if you agree with me that energy is force and force is mass times acceleration, then therefore, that means for ladies, then that means I will have kg. Acceleration is what? Meter per second square times distance m. So therefore, final answer will be kg meter square per second square. So our answer for energy is what? Kg meter square per second square. That means option A says what? Kg meter cube, kg per meter cube per second square. B says kg meter per meter per second square. C says what? Kg meter cube per second square. Then D says what? Kg meter square per second square. So option D is the right answer. Number 14, he said the dimension of electromotive force are dash. Electromotive force. Electromotive force is what we call the EMF. EMF, electromotive force, which is what? The nominal PD. So power is equal to I times E, which is input power. So therefore, our E, which is electromotive force, is equal to what? Power divided by what? By current. Don't forget, power equal to IV. You know, power equal to IV. This is output power. If this one is the EMF of the cell, this input power. So, and what I want to do now is simply what? Take what? Power is what? This ML, we have done that one before. T ML square, T minus 3. What is dimension for current? Current is what? I. So our final answer becomes ML square, T minus 3, then I raised power minus 1. Don't forget that I told you dimension power of current is I or A. So it depends, but I is common. So the dimension of that question, option A says what? ML squared T minus 3, I raised power minus 1, which is the answer to that question, option A. But option B says ML squared T raised power minus 3, then I raised power minus 2. No, wrong. This one says what? ML squared T M square L T square I raised power minus 1. This is M square L square T minus 1 I minus 1. So the answer to that question is option A. We meet in the last section. Thank you.